Hi guys, Mrs. Geiger here, and I am going to record a Unit 3 periodic table review. So if you are watching this for the unit test or for the Regents exam, I'm going to go over everything you need to know from Unit 3. All right, so I'm going to remind you that you have this packet, Trends in the Periodic Table, which we used when we very first started this unit to get used to the trends. So this is a very good packet to go back and review before you start any other studying. All right, so we're back here, and the very first thing is groups and periods. The main way in which the periodic table is organized is that groups go up and down, they're vertical, and periods go left to right, they're horizontal. Groups, all of the elements in the same group have the same number of valence electrons, which means that they react similarly. Mendeleev, when he created the periodic table, grouped elements by how they reacted, not understanding their electronic internal structure. We now know that their internal structure is what's causing them to have similar chemical properties. Elements in the same period have the same number of orbitals. So the period number tells you the number of orbitals that that element has. All right, so all of the elements in period 3 have 3 orbitals of electrons. All right, atomic radius is the distance from the nucleus to the valence electrons. It's measured in picometers. And remember that there's 1 × 10⁻12 picometers in 1 meter. It's just a different way to talk about the distance. And so we know that the radius, just like the radius of a circle. All right, so as you go from top to bottom down a group, the radius is going to increase, and that's because the number of orbitals increases as you go from the top to bottom down the same group. And as you go left to right across a period, the radius is going to decrease. This is back to the end puzzle that you watched where I showed you why this happens. And I'm going to remind you of the atomic radius snowman. As you go down, it kind of looks like a snowman. As you go left to right across a period, the radius decreases even though you have the same number of orbitals. This is due to an increased nuclear charge or an increased number of protons. So as the number of protons increases, they're going to pull on the electrons more, pulling them closer into the nucleus, therefore decreasing the radius. So here's a little graphic that we talked about in class where the radius increases as you go down, but it decreases as you go left to right. You kind of can think of it as the snowman falls over, and that's because of the increased nuclear charge. All right, so once you know the trend in radius, you can figure out all of the other trends because all of the other trends are due to the radius trends. So electronegativity is defined as an atom's attraction for electrons within a bond. This is going to become the most important factor from this unit as we move forward throughout the year, so it's really important to understand this. As the radius increases, the electronegativity is going to decrease as you go down a group, and as the radius decreases as you go left to right across a period, the electronegativity is going to increase, with the exception of noble gases, which do not have any electronegativity. Remember, electronegativity is a little weird. It does not have a unit, but instead is on a 0 to 4 scale. First ionization energy is the amount of energy it takes to make an ion, but to make an ion by removing an electron. So it's the amount of energy required to remove the most loosely bound electron from an atom to form an ion. So the larger an atom is, the less energy it takes to remove its most loosely bound electron. Don't forget that a positive ion is called a cation, and first ionization energy is measured in kilojoules per mole, and moles is just a way to measure the amount of a substance. So you can think of it as the energy that is needed to remove an electron. The next thing we talked about was the 3 categories of the periodic table: the metals, the nonmetals, and the metalloids. all of the elements to the left of the staircase are considered to be metals. Almost all elements are metals, actually. And metals have the following characteristics, where they have low ionization energies, low electronegativities, and they're usually solids at room temperature. And they are ductile and malleable, and there's the definitions there of ductile and malleable. And they're good conductors of both heat and electricity. They have metallic luster, which means that they are shiny. They make cations, which is positive ions. And all of the properties of metals are due to the fact that they are losers. Metals have very low first ionization energies, therefore it does not take a lot of energy to remove their electrons. And that's what causes them to be shiny and be good conductors. Nonmetals are just the opposite. They're all the elements to the right of that staircase, not including the last group. All the properties of nonmetals are because they hold on to their electrons very tightly. So they form anions, which remember are those negatively charged ions that are formed by gaining electrons. They have high electronegativity and high first ionization energy. They're brittle in the solid form, and don't forget, brittle means that when you push on them, they will crumble instead of bend. And they are insulators, meaning they do not conduct heat and electricity very well. They lack luster or they are dull. They are gases, liquids, network solids, and molecular solids at room temperature. The last category is metalloids. There's nothing specific to know about metalloids except for that they have some properties of metals and some properties of nonmetals. You'll remember from the lab we looked at some silicon. Silicon has luster, but it's brittle. It's a good conductor of electricity, but it's a poor conductor of heat. So it's a good example of a metalloid. There are 4 special groups that you need to know the names of. Those groups are the first group, the second group, and the last 2, the 17th and the 18th groups. They get special names. Group 1 is called the alkali metals, and group 2 is called the alkali earth metals. Group 17 is called the halogens, and group 18 is called the noble gases. Don't forget the octet rule. The octet rule says that all atoms are stable with 8 valence electrons, which means that their S and their P sublevels are full, and all bonding occurs to achieve an octet for all atoms. We also, in honors, talked about some anomalies in your trends. So here's an example of that first ionization energy graph. And a zoomed in different version of that graph would be here. So just remember that full sublevels have a special level of stability, and also half-full sublevels, such as nitrogen, which has those 3 unpaired p electrons. This won't be on the Regents, but there will be a question about these anomalies on your test, your honors test. All right, so that's it. For the entire periodic table unit, do lots of practice problems, and remember that you can always recreate the trend. Remember, you can always recreate the trends using table